Assalamualaikum, my name is Muhammad Alif Aiman. Today I would like to present about for the part introduction. Uh, for the camera parameter are the parameter used in a camera model to describe the mathematical relationship between 3D coordinates of a point in the scene from which light come from and the 2D coordinate of its projection onto the image plane. So we have two parameter, intrinsic parameter, which mean internal parameter, which the parameter intrinsic to the camera itself. They have two focal length and length distortion. For the second parameter is extrinsic parameter, uh, which mean external parameter or camera pose, which used to describe the transformation camera and its external worlds. For the part objective, uh, to analyze vision system problem using technique and concept of vision system engineering. For the second objective is organize a group teamwork to construct a complete vision system module for certain application related with mechatronic system. For the third objective is to demonstrate the importance of vision system in current technology for sustainable development. And lastly, objective is to investigate and solve vision system problem using technique and concept of vision system engineering. So this is my phone specification. I'm using Apple iPhone 11 for the camera, rear camera, dual camera. For the main camera, uh, there is 12 megapixel. For the specification, aperture size f1.8, focal length 26 mm, sensor size 1/2.55, pixel size 1.4. Second camera is 12 megapixel, ultra wide sapphire crystal cover. Specification aperture size f2.0, focal length 13 mm. For the video recording 3840 time 2160, 4K HD, 60 fps, 1920 times 1080 full HD, 240 fps, 1280 times 270 HD. For the front camera is 12 megapixel, AES, HDR slow motion video. That's all from me. Assalamualaikum. Uh, my name is Muhammad Alif Aiman. I would like to demo for Semester 1 vision system. First of all, we go to camera calibrator. Okay, after that we add image from file. So we searching for the folder that I put the image. So this is all my image that I have captured, 10 image. So now is detecting checkerboard in image of 10. So that we press OK. So as you can see, we get 10 image. So this is the first image. For the green, this is green, or of green is stand for detected point. For the square yellow square, this one, stands for the checkerboard regime. So after that, we calibrate. And we get the overall mean error is 0.28 pixel. This is my camera centric. So this is my camera, and this is what output I'm get from my picture I take, the angle. Okay, this is pattern centric. Okay, after that we export camera parameter, and then we generate MATLAB script. Okay, this is define image to process. There is 10 for the 10 image that I have used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, after that we save as to the one folder. Okay, when we save that, we run this code. We enter add to path. Okay, this is a figure for extrinsic parameter. This is my camera, and this is angle that out from my camera. Yeah, there is 10 angle. Okay, we close out this. So this is overall mean error 0.28 pixel. This is for picture 1, for picture 2, 3, 4, 5, 6, 7, 8, 9, and for the picture 10. Okay, so this is for the intrinsic from camera calibrator. So this is my focal length pixel. This is the value. After that, the principal point pixel. This is the value. After that, radial distortion. This is the value. And extrinsic rotation vector. We have 10 value for the 10 image. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is translation vector. We have also 10 because we have 10 image. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this value of translation vector. So that's all from me for the demonstration of 7.1 vision system. Thank you.
Assalamualaikum. I'm Muhammad Abdul Karim Abdurrahman Ahmed, with matric number of BE190009. In this presentation, I'm going to present the histology part and the MATLAB simulation. So this assignment 1, our subject is vision system. The subject code is BEJ34202. This presentation is from group 11, section 2. Section 1 under Dr. Duati Binti Bahardin. So first, to start our assignment, we need to use the toolbox calibration in MATLAB. So we can get the latest vision from Google to get the camera calibration toolbox. Then we proceed to the extract grid corner of the image. So in this during this process, the MATLAB software will ask us for our image name and image format. So then we need to proceed to the calibration. Before we proceed to the calibration, we make sure that our pictures are already detected from the extract grid corner. So then we need to proceed to the calibration. So then show the extrinsic word camera center, then analyze image, and then undistorted image, then the int. So next is as our assignment need a smartphone to capture the checkable pictures, so minimum of 10 pictures. So I'm using, my phone is Techno Spark AC. So what is the camera setup on the Spark AC? On the back side, the Spark AC features are dual camera setup, which consists of a 13 megapixel main camera and an AI lens, as we can see at the pictures that provided at the slide. And also the rear facing camera has features such as AR stickers and HDR mode, and also AI scenes recognition. The time-lapse mode and OK mode. On the front side, which is the selfie, the device boasts an 8 megapixel selfie camera. So as we can see here, also the main camera is dual 13 megapixel, pictures are 1.8 and 27 millimeters. So this is the also support QVGA, and also the features are dual LED flash and also HDR. The video are 1080 pixels at 30 pixels. The selfie camera are single is 8 megapixels. The pictures are LED flash. So next, these are the pictures that I already captured and processed with MATLAB software. So for team picture, my format is JPG. So this is the intrinsic values that I have got from the simulation. For the intrinsic, the focal length values are, these are the values are measured in pixels. So this is alpha and this is beta values. The principal point are in pixels, also measured in pixels, and radial distortion. So next, this is the extrinsic rotation vectors value. Then this is the translation vectors, also measured in millimeters. Here, as you can see in figure 1, this is the main reprojected errors in peer image. So the overall main errors that we obtain is 0.24 pixels. So that means our image error are less than 1 pixel. So that means it's good to proceed for the calibration, because it's already the main errors are less than 1, is 0.24 pixel, less than 1 pixel. So next, here as you can see the extrinsic parameters visualization for figure 2. This is the camera fixed in one position. Then we need to move only the objective, which is the checker border that we have printed out. So just we need to move it, no need to move the camera because already fixed it in one position. So let's see the MATLAB MATLAB software calibration. So I use the apps, which is the camera calibration, that will ask for the adding the pictures that I already saved in my PC. So this is we add from file. So this is the pictures that I already take the pictures. So 1 2 3 4 5 6 8 9 10 11 12 13 14. So these are my pictures that I already captured from my smartphone. So this is the checkerboard. So we ask for the 25 millimeters. So the size already in 25 millimeters. So the image distortion is low. So this is the analyzing image for detecting the checkerboard, which is tell us if our images are accepted or not. Let's see what happened. Okay. This is the green color is detected points for detecting the points, and the yellow for the checkerboard organ. So we need to make sure that all our image for the checkerboard organ is at the same corner. So as we can see in image 2, in the same corner, this is X direction and this is Y direction, so are already in Z direction, the checkerboard organ. So all my images are the at the same organ. So that's mean it's already good to calibrate, so that we can get the results. We proceed to calibration. This is the camera centric. The camera centric is already, as I mentioned before in the slide previously. So this is the camera that fixes in one position. So we need to just remove our image, no need to move the camera. So this the patron centric, that we need to move the camera, but no need to move the checkerboard, the image. So as I did, I just put the checkerboard image in one place, then I move the camera, I move my phone to capture all the pictures. So, and also this is the main reprojected errors. So overall, as I mentioned before, overall main errors are 0.24 pixels, so less than 4. So okay, let's generate the MATLAB script. So when we generate the MATLAB script, then we need to publish the script to get, okay, publish, save. To get the MATLAB calculations, extrinsic and intrinsic values, and the figure for figure 1 and figure 2 for the main reproductive mean errors, and also the extrinsic parameters visualization. Okay. Okay. Before, okay, this is figure 1, which I explained before, the main reproductive errors in peer image. So the overall mean errors are 0.24 pixels. Okay, and also this is the extrinsic parameters visualization, which is the centric, the camera centric, which is already I explained before. So now we need to see the values for the camera intrinsic and camera extrinsic. So now we can see, as we can see, the pattern extrinsic are 14 times 1 form form 3D. And okay, now we can see the intrinsic values, which I explained before. The focal length measured in pixel, and also the principal point measured in pixel. This is the alpha values, and this is beta values for the principal point. Also, this is this value for the principal, and this radial distortion. So now this is the extrinsic values, extrinsic rotation vectors, and this is the translation vectors measured in millimeter also. And then these are the main reprojected error in peer image, and also this is the extrinsic parameters visualization. So that's all about me, and thank you very much.
Great day, Doctor. My name is Yoganathan, son of Botumalai, metric number DE190094. I'm from Group 11, so going to explain about the conclusion for the assignment 1. Before that, let me explain about the phone specification. So for this assignment 1, the model that I use is Samsung Galaxy A31. So this model consists 4 cameras. So the main camera consists of 48 megapixel, the second one is 8 megapixel, third one is 5 megapixel, and the last one is 5 megapixel. So for this assignment, I used the main camera, which is 48 megapixel. So before that, let me demonstrate how to do the calibration in the MATLAB software. So once we open the MATLAB software, the top there got 3 plots, which is home, plots, and applications. I mean apps. So try to click the apps and try to search for the camera calibrator. So try to click it. So once we click the camera calibrator, it says appear like this. So from here, we can add the images of the checkerboard that I've already captured through my phone. So there are 10 types of images that I've captured in a different angle or other way in view. So try to insert all the 10 images. So from here, we can see it will ask the checkerboard square size. So in the assignment already stated, it is 25 millimeter. So press OK. So we will wait until detect the checkerboard each by each of the image. Okay, done. So you can see the 10 images are inserted ready in the camera calibrator. So from here, we can see the green color dot shows that the detect points, and the yellow color shows about the checkerboard origins. So we try to check each image whether is correct or not. Okay, good. So next, we try to click calibrate. So once we click the calibrate, from here we can see the results for each images. So from here we can see the reprojection errors for each image, and down here we can see the view of the checkerboard and the cameras. So this one, the checkerboard is a static mode. So the colors one, the numbers one are the view of the cameras. So this one, the camera will be in the static mode. So the checkerboard will be in the sideways. So the top one, from the reprojection errors, we can see all the images got their errors, but the image number 10 consists more errors because it's not in the static host. So after we're done, we export the camera parameters. So we try to click the generate MATLAB script. So we can see here, it's already calibrated here. So define image to the process. So the each image got processed through this calibration. So from here we can see detect the checkerboard in image, read the first image to obtain the image size, generate world coordinates of the corners of the space, calibrate the camera, view reprojection errors, visual pattern location, display parameter estimation errors, like that. So then we run the simulation. For that, we need to save this file. So I save it as assignment 1. Here we can see the results of the calibration. So it shows the intrinsics of the focal length pixels, principal point pixels, radial distortions. In the extrinsics shows the rotation vectors, translation vectors, but everything is in millimeter because we done in the millimeters. Next, let me explain about each of these results. So these are the defined image as I said earlier before. So these are the 10 images that already calibrated in the MATLAB. So these are the intrinsics that I stated. It shows about the focal length, principal points, skew, radial distortion, tangles and distortion. And for the stick, it shows the rotation vectors. Next one is the translation vectors. So this one's the camera parameters. So in this camera parameter shows about the camera intrinsics, camera extrinsics, accuracy of estimation, calibration settings. So this one's the estimation errors. So this one is the mean reprojection errors per image. As I stated, the image number 10 consists more errors. So this is the extrinsic parameters visualizations. This one. As I said, this one is the camera is the static mode, and this one is the checkerboard in the static mode. So next one. This is the undistorted image versus the original image. The top one is the original image, and the bottom one is undistorted image. So compared to the original image, undistorted image, the original image is more clear and more colorful compared to the undistorted image. It looks more white and blue. So these are the 10 images of the undistorted image versus the original image. So for the conclusion of this assignment 1, as a result from this assignment 1, we learned how to do an intrinsic and distortion coefficient parameters determination from smartphones. At the same time, we also able to use the MATLAB application to calibrate the checkerboard, which captured using different types of smartphones in our groups. So finally, we can observe that each smartphone produced different type of extinction of grid corner, rejection error, extinct parameters, and calibration image. So that's all from me. Thank you.